For protecting electrical connectors and electronic components at temperatures below -20°C, consider the following greases and chemicals. Firstly, silicone grease offers excellent protection against moisture, oxidation, and temperature extremes. Secondly, fluorocarbon grease is highly resistant to cold temperatures and wear, but can be expensive. Thirdly, perfluoropolyether, or PFB grease, is exceptionally chemically inert and stable at low temperatures. Consider these chemicals. Firstly, conformal coatings are thin, protective layers applied to circuit boards and components to prevent moisture, dust, and corrosion. Secondly, electronic cleaning solutions are non-flammable solvents used to remove contaminants from connectors. Thirdly, contact enhancers are applied to connectors to improve electrical conductivity and prevent corrosion. Here are some recommended products. Nirogel 760. G is a silicone grease with a temperature range of -40°C to +200°C. Dow Corning Molykote Fluorolube 85.41 is a fluorocarbon grease with a temperature range of -55°C to +200°C. Fluorogard PFG1 is a PFB grease with a temperature range of -65°C to +260°C. Tick Spray Electrosolve 900 is a non-flammable electronic cleaning solution. Cake Deoxide E100. L is a contact enhancer that prevents corrosion and improves conductivity. For application instructions, firstly, clean connectors and electronic components thoroughly with an electronic cleaning solution to remove any dirt or debris. Secondly, apply a thin layer of grease or conformal coating to the connectors and components as recommended by the manufacturer. Thirdly, allow the grease or coating to dry or cure according to the manufacturer's instructions. Here are some additional tips. Firstly, use a clean, lint-free cloth or brush to apply the grease or coating. Secondly, avoid over-lubrication as this can attract dirt and debris. Thirdly, regularly inspect the connectors and components for signs of damage or excessive wear. Fourthly, consider using electrical tape or other protective measures to further shield the connectors and components from the cold. When selecting a grease, consider the operating temperature range. Ensure the grease remains effective and doesn't become too viscous or solidify at -20°C or lower. Silicones typically perform well at low temperatures and offer good resistance to moisture and oxidation. Fluorocarbon greases offer excellent performance at low temperatures and are resistant to a wide range of chemicals. PFB greases are exceptionally stable and inert, making them suitable for extreme environments. Always check the manufacturer's specifications to verify their suitability for low-temperature applications. Conformal coatings provide a protective barrier against moisture, dust, and other contaminants that can affect electronic components. They are available in various materials such as acrylic, silicone, epoxy, and urethane. Choose a coating that is specifically designed for low-temperature applications and provides adequate protection against the elements. Consider the application method and cure time when selecting a conformal coating. Ensure the coating is compatible with the components and materials used in the electronic system. Electronic cleaning solutions are used to remove contaminants such as dirt, oil, and corrosion from electrical connectors and electronic components. Use a non-flammable solvent specifically designed for electronic cleaning. Ensure the cleaning solution is compatible with the materials used in the connectors and components. Follow the manufacturer's instructions for proper cleaning procedures. Contact enhancers improve electrical conductivity and prevent corrosion on connector surfaces. They typically contain conductive particles or chemicals that create a better electrical connection. Apply contact enhancers sparingly to clean connector surfaces. Avoid using excessive amounts, as this can attract dirt and debris. Consider using a contact enhancer with corrosion inhibitors to further protect the connectors. When applying grease or conformal coatings, use a clean, lint-free cloth or brush to ensure even coverage. Avoid over-lubrication, as this can attract dirt and debris and potentially interfere with the electrical connections. Follow the manufacturer's instructions for proper application techniques. Regularly inspect the connectors and components for signs of damage, corrosion, or excessive wear. Replace or repair any damaged components to prevent further problems. Reapply grease or conformal coating as needed to maintain optimal protection. Consider using electrical tape or other protective measures to further shield the connectors and components from the cold and other environmental factors. Wrap connectors with electrical tape to provide an additional barrier against moisture and dust. Use heat shrink tubing to protect exposed wires and connections. Consider using enclosures or housings to protect electronic components from the elements. Always follow the manufacturer's recommendations for specific products and application techniques. Consider consulting with a qualified engineer or technician for guidance on selecting and applying the appropriate protective measures for your specific application. Keep in mind that proper maintenance and inspection are essential for ensuring the long-term reliability of electrical connectors and electronic components in extreme cold environments. Regularly clean and lubricate connectors, inspect for damage, and replace components as needed. By following these guidelines, you can protect your electrical connectors and electronic components from the damaging effects of cold temperatures and ensure reliable performance in demanding environments. Remember to consult safety data sheets for all chemicals used and wear appropriate personal protective equipment. Always disconnect power before working on electrical equipment. Consider the specific requirements of the electrical lift truck and its operating environment when selecting protective measures. Factors such as vibration, humidity, and chemical exposure may influence the choice of greases and chemicals. Implement a preventative maintenance program to regularly inspect and maintain electrical connectors and electronic components. This will help to identify and address potential problems before they lead to failures. Train personnel on proper procedures for handling and maintaining electrical equipment in cold weather conditions. This will help to ensure that equipment is used and maintained safely and effectively. By taking these steps, you can minimize the risk of electrical failures and ensure the reliable operation of the electrical lift truck in cold weather environments. Always prioritize safety and follow established electrical safety practices. If you are unsure about any aspect of electrical maintenance or repair, consult with a qualified electrician or technician. Regular inspections should include checking for loose connections, damaged wiring, and signs of corrosion. Use appropriate tools and equipment for electrical work, and always follow safety precautions. Consider using dielectric grease on electrical connections to prevent moisture intrusion and corrosion. Dielectric grease is a non-conductive grease that helps to seal out moisture and contaminants. Apply dielectric grease sparingly to clean connector surfaces. Avoid using excessive amounts, as this can attract dirt and debris. When selecting electrical connectors, choose connectors that are specifically designed for use in harsh environments. These connectors typically have robust construction and environmental seals to protect against moisture, dust, and vibration. Consider using shielded cables to protect against electromagnetic interference. Shielded cables have a layer of conductive material that helps to block electromagnetic radiation. Ensure that all electrical connections are properly grounded to prevent electrical shock hazards. Grounding provides a path for fault current to flow back to the source, tripping a circuit breaker or fuse and preventing electrical shock. Follow the National Electrical Code, or NEC, and other applicable electrical codes and standards. The NEC provides guidance on safe electrical practices and installation methods. Consult with a qualified electrical engineer to ensure that the electrical system is designed and installed in accordance with applicable codes and standards. Regularly test the electrical system to ensure that it is functioning properly. Use appropriate test equipment to measure voltage, current, and resistance. If you detect any abnormalities, investigate the cause and take corrective action. Keep a record of all electrical maintenance and repairs. This will help to track the performance of the electrical system and identify any recurring problems. Review the electrical system periodically to identify opportunities for improvement. Consider upgrading components or systems to improve performance, reliability, or safety. By following these best practices, you can ensure the safe and reliable operation of electrical equipment in cold weather environments. Remember that electrical safety is paramount, and always prioritize safety in all electrical work. If you have any doubts or concerns, consult with a qualified electrician or technician. When dealing with extreme cold, also consider the impact on batteries. Low temperatures can significantly reduce battery capacity and performance. Use batteries that are specifically designed for cold weather applications. These batteries typically have a higher energy density and can operate at lower temperatures. Keep batteries warm when possible. Consider using battery warmers or insulated battery boxes to maintain battery temperature. Regularly charge batteries to ensure that they are fully charged. Low battery voltage can lead to equipment malfunction or failure. Inspect batteries for damage or corrosion. Replace any damaged or corroded batteries to prevent further problems. Follow the manufacturer's recommendations for battery charging and maintenance. Use appropriate battery chargers and follow the recommended charging procedures. Dispose of batteries properly. Batteries contain hazardous materials and should be recycled or disposed of in accordance with local regulations. By following these guidelines, you can maximize battery performance and lifespan in cold weather environments. Remember to prioritize battery safety and follow established battery safety practices. If you're unsure about any aspect of battery maintenance or repair, consult with a qualified technician. For instance, if the equipment uses lithium-ion batteries, be especially careful. Lithium-ion batteries are sensitive to temperature extremes and can be damaged by overcharging or discharging at low temperatures. Use battery management systems to monitor battery temperature and prevent overcharging or discharging. Store lithium-ion batteries in a cool, dry place. Avoid storing batteries in direct sunlight or near heat sources. Follow the manufacturer's recommendations for lithium-ion battery charging, storage, and disposal. Always use appropriate personal protective equipment when handling batteries. Wear gloves and eye protection to protect against battery acid and other hazardous materials. Be aware of the potential hazards associated with batteries and take appropriate precautions. If you encounter any problems with batteries, consult with a qualified technician. Also, consider the impact of cold weather on other components of the electrical lift truck. Hydraulic fluids can become more viscous at low temperatures, affecting the performance of hydraulic systems. Use hydraulic fluids that are specifically designed for cold weather applications. Lubricate all moving parts regularly to prevent friction and wear. Cold weather can cause components to contract and become brittle. Inspect all components for cracks or damage. Keep the equipment clean and dry to prevent corrosion. Consider using enclosures or covers to protect equipment from the elements. By taking these precautions, you can minimize the impact of cold weather on the electrical lift truck and ensure its reliable operation. Remember to follow all safety guidelines and consult with qualified technicians as needed. The information provided here is for general guidance only and should not be considered a substitute for professional advice. Always consult with qualified professionals for specific recommendations and solutions tailored to your particular situation. Proper maintenance, inspection, and repair are essential for ensuring the safe and reliable operation of electrical equipment in all environments. Adhering to safety guidelines and seeking professional assistance when needed will help to prevent accidents and ensure the longevity of your equipment. Be sure to consult the equipment's manual for specific instructions. Regarding the NEC, the most relevant articles would be Article 300.3, which discusses the integrity of electrical connections, and Article 310.15, which addresses ampacity correction factors for temperature. However, those tables are not meant to address temperatures as low as -20 degrees Celsius. Instead, the NEC is more for above-ground ratings of wire. The ampacity correction factor is for maintaining wire ratings in high temperatures, not low temperatures. But the spirit of the NEC can still be applied for extreme cold. For example, if a wire is rated for 30 ounce at 30 degrees Celsius, the NEC provides a way to calculate its rating at, say, 70 degrees Celsius. Conversely, it can be reasoned that an opposite methodology be used to determine the suitability of that same wire at -20 degrees Celsius. The primary concern would be the wire insulation becoming brittle and cracking. The choice of wire used would be a major factor. The electrical lift truck, also known as a forklift or powered industrial truck, relies on its electrical system for various functions including powering the motor, lights, and control systems. Ensuring the reliability of these electrical components is critical for safe and efficient operation. In extremely cold conditions, several challenges can arise. The resistance of conductors can increase slightly at very low temperatures, leading to reduced current flow. However, this effect is generally not significant enough to cause major performance issues in properly designed systems. The main concerns relate to the embrittlement of materials, increased risk of condensation, and reduced battery performance. The key is to use components rated for the expected temperature range, apply protective coatings and lubricants, and implement a regular inspection and maintenance program. For example, standard PVC insulation may become stiff and prone to cracking below -20 degrees Celsius. Alternatives like silicone rubber or cross-linked polyethylene offer better flexibility at low temperatures. Similarly, standard connectors may lose their sealing properties, allowing moisture to enter and cause corrosion. Use environmentally sealed connectors with appropriate temperature ratings. When selecting components, always refer to the manufacturer's specifications and choose products tested and certified for use in extreme cold environments. Consider the potential for condensation to form inside enclosures as temperatures fluctuate. Use enclosures with adequate ventilation or consider adding desiccant packs to absorb moisture. Also, ensure that any drain holes are kept clear to allow water to escape. Proper grounding is essential for safety and to prevent electrical noise from interfering with sensitive electronic controls. Check grounding connections regularly to ensure they are clean and tight. Corrosion is a major concern in cold, damp environments. Apply corrosion inhibitors to exposed metal surfaces and use dielectric grease on electrical connections. Pay particular attention to connectors, terminals, and splices. Wiring harnesses should be properly supported and protected from abrasion. Use cable ties and clamps to secure the harness and prevent it from rubbing against sharp edges. Regularly inspect wiring for signs of damage, such as cuts, cracks, or frayed insulation. Replace any damaged wiring immediately. The control system is the brain of the electrical lift truck. It is responsible for controlling the motor, steering, braking, and other functions. The control system is often the most sensitive part of the electrical system and is susceptible to damage from cold temperatures. Use control systems that are specifically designed for use in harsh environments. These systems typically have robust construction and environmental seals. Protect the control system from moisture, dust, and vibration. Consider using an enclosure or cover to protect the control system from the elements. Regularly inspect the control system for signs of damage or malfunction. Replace any damaged or malfunctioning components immediately. Motors used in electrical lift trucks are typically DC or AC motors. These motors can be affected by cold temperatures. The performance of the motor can be reduced at low temperatures. The motor can become more difficult to start. The motor can be more prone to overheating. Use motors that are specifically designed for use in cold environments. These motors typically have special insulation and lubrication. Keep the motor clean and dry. Protect the motor from moisture, dust, and vibration. Regularly inspect the motor for signs of damage or malfunction. Replace any damaged or malfunctioning components immediately. Lighting is essential for safe operation of the electrical lift truck. The lighting system should provide adequate illumination for the operator to see clearly. The lighting system should be reliable and durable. The lighting system can be affected by cold temperatures. The performance of the lighting system can be reduced at low temperatures. The lighting system can be more prone to failure. Use lighting systems that are specifically designed for use in cold environments. These systems typically use LED lights, which are more efficient and durable than incandescent lights. Keep the lighting system clean and dry. Protect the lighting system from moisture, dust, and vibration. Regularly inspect the lighting system for signs of damage or malfunction. Replace any damaged or malfunctioning components immediately. Brakes are essential for safe operation of the electrical lift truck. The braking system should provide adequate stopping power. The braking system should be reliable and durable. The braking system can be affected by cold temperatures. The performance of the braking system can be reduced at low temperatures. The braking system can be more prone to failure. Use braking systems that are specifically designed for use in cold environment. These systems typically use hydraulic brakes, which are more reliable than mechanical brakes. Keep the braking system clean and dry. Protect the braking system from moisture, dust, and vibration. Regularly inspect the braking system for signs of damage or malfunction. Replace any damaged or malfunctioning components immediately. Tires are essential for safe operation of the electrical lift truck. The tires should provide adequate traction. The tires should be durable and resistant to wear. The tires can be affected by cold temperatures. The performance of the tires can be reduced at low temperatures. The tires can become more brittle and prone to cracking. Use tires that are specifically designed for use in cold environments. These tires typically have a special tread pattern and rubber compound. Keep the tires properly inflated. Inspect the tires regularly for signs of damage or wear. Replace any damaged or worn tires immediately. Regular maintenance and inspection are essential for ensuring the safe and reliable operation of the electrical lift truck in cold weather conditions. Follow the manufacturer's recommendations for maintenance and inspection. Keep the equipment clean and dry. Lubricate all moving parts regularly. Inspect all components for signs of damage or wear. Replace any damaged or worn components immediately. By following these guidelines, you can minimize the risk of electrical failures and ensure the reliable operation of the electrical lift truck in cold weather environments.